If you remember all the way back to chapter 2, we talked about finding the average velocity of something in motion by finding its change in distance and dividing by the change in the time that it took. We also talked about wanting to understand, wanting to compute, wanting to figure out how fast we were going at an exact moment instead of the average over time. So we said we could let that change in time get smaller and smaller, and once we came to understand limits, we found out that we could actually compute instantaneous velocity. Now that we've had some experience in chapter 2 and the beginning of chapter 3, we can recognize what we did, taking the limit as the change in time approached zero of a big difference quotient as a derivative. So here, this is my graph for distance. I've taken the derivative essentially, and what I've computed is velocity. So ladies and gentlemen, velocity is the first derivative of position. This is the beginning of our connection between calculus and physics. So maybe you've seen some of this notation, some of these kinds of functions in your physics class. It's normal, probably in your physics class, to use S of t, or S, to stand for a position function. We'll do that frequently in calculus too. We'll talk about some other ones as well. So I could say that V of t equals S prime of t. Or I could use that other notation for the derivative. I could say V of t equals ds dt. So you have to be very careful to remember S is position and not speed. Sometimes speed and velocity accidentally get used interchangeably, but they're not the same. Velocity could be positive or negative. Velocity is what we call a vector function. It has both a direction and a magnitude and a value to it. Speed, however, only has a value. It's always positive. Specifically, speed, guys, is the absolute value of velocity. So we could say speed is the absolute value of the first derivative of the position function. There are two important things to know about velocity, the kinds of things that come up on the AP test. A body is at rest if its velocity is zero. So here's an example problem that was actually on the 1988 multiple choice test. If I have this formula for position, x of t is t cubed minus 3t squared minus 9t plus 1, I've been asked for what value or values of t is the particle at rest. Well, I just found out. A particle is at rest if its velocity is zero. So I'm going to find the velocity, and I'm going to set that equal to zero. So you can see that's what I've done down here. V of t, I know, is the derivative of position. So I've taken the derivative of my x of t function. I get 3t squared minus 6t minus 9. And I know that I want the velocity to equal 0, so I've set velocity equal to 0. I can solve this equation. I get two solutions. You notice that I've crossed out -1 as a possible solution. That's because of the statement in the original problem, limiting the domain of the x function. Since velocity is the derivative of the x function, derivatives take on the domain of their father function, so whatever function they were derived from. So I can't include in the derivative of the velocity which is the velocity function, any value that is not in the domain of the original function. That's why I've crossed out the -1, and I would say that the particle is at rest at exactly time t equals 3. The other important velocity fact, if velocity is positive, then motion is forward, whatever forward means in the context of the problem. So if I'm driving to school and my velocity is positive, I'm driving toward school. If I'm driving to school and my velocity is negative, I'm going away from the school. My motion is backward. And then based on this understanding that negative velocity means motion backward and positive velocity means motion forward, we can conclude that direction changes when velocity changes, either from positive to negative or negative to positive. So here in this problem, I have the graph of the velocity of a particle. This only works because I have the velocity graph. I think at time t equals 3, velocity changes from negative to positive. At time t equals 5, the velocity changes from positive to negative. I would say that the particle changes direction at time t equals 3 and t equals 5.